It's crazy. Okay, so the last item here, the last item that I'm going to teach you a little computation on the calculator is how to find the z-score for a particular percent. Okay, on the calculator. So before we've done that, those numbers 6 through 11 on your homework, you did on your z-chart. Okay, so now I'm going to show you what this thing called inverse norm is on your calculator. When you use inverse norm, you have to reference the area below the z-score. And it has to be a percent in decimal form. So, let's look at the first problem. Find the z-score for the lowest 10% of data. Okay, so if I'm taking a look at the picture of this, and I've got this lowest 10% of data, okay, this question is, what is this z-score? So what is this cutoff value right here? Okay, well, what we did yesterday, or on last night's homework, was we looked that up in the z-chart. So let me show you, let's look at that real quick. In the z-chart, it's the negative side, so find the 10%, and that's located about right here. Okay, so that's at negative 1.28 or 289, yeah, negative 1.28, closest to that. Okay, but if we want to do this problem in our calculator, then what we are going to put in, and I'll show you where it is in a second, is we're going to do inverse norm, so it's going backwards, and you put 0.10 or 0.1 in there. So you're putting the area below that z-score in there. And here we go. It is located in the same place that your other information was. It is in second bars. So press second bars, which is next to the clear button. Go down to inverse norm and put in your 0.1 or your 0.10, whatever your percent is, and you hit enter, and boom, there you go. You got your negative 1.28, which is the same thing that we determined it was when we looked at the z-chart right here. Okay? So it's giving you the same thing, whether you choose to do it in your calculator or on your z-chart. You are still going to, your location right here is negative 1.28. Okay, that's how many standard deviations that is below. You could, yes, you could. So for number 2, though, this is an example of one with the highest. Number 2 says, find this cutoff right here. What is this z-score for the highest 5%? Well, the issue is that when you put this in your calculator, it has to be for the lowest area. So if you have 5%, it's the highest amount, then what's the lower part? Okay, good. So when you put this in your calculator, what you're actually putting in is inverse norm of 0.95, and then that's how you get your positive 1.645. Okay, so you could go through that and do that. Second bars, inverse norm of 0.95 is how you get 1.645. Okay, now, what if I want to do is the cutoffs for the middle 50% of data? I actually am going to have 2 answers, because I'm going to have a location of this lower z-score and a location of this higher z-score, so I will have 2 values on this problem. So, you need to know what's below. So what is in this shaded area right here? Good, 25%. Okay, because both tails are going to contain your 25%. So I'm going to go inverse norm of 0.25. And when you do that, you get negative 0.6745. So that is this z-score right here. Now, you're welcome to just use your brain and know that this is symmetrical. And since this is symmetrical, what is this upper z-score going to be? Positive 0.6745. Now, if you wanted to do this and like quote, check yourself in the calculator, what amount of area is this below this upper z-score? 75% is below that. So if I did inverse norm of 0.75, okay, if I want to look at this in my calculator and I do inverse norm of 0.75, then I would see that I would get that positive 0.6745. Okay, which you said that that's what that is. Okay, very good. So what I want you to do is numbers 4, 5, and 6, and then we'll check those. So take a moment, do 4, 5. No, actually I should probably say that. So you have two answers on this number 3. One answer is negative 0.6745, and the other answer is positive 6745. See, the question asked for z-scores. There's two answers because there's two z-scores that you were supposed to get on that one. So those problems, you have two values. Okay, so finish those up. What does it mean, what? Oh, it's supposed to be the middle 20. Like the middle 20%. Like this was the middle 50%, middle 20%. So middle 20%, yeah. If this is your 20%, then there's going to be, no. If 20% is here, then how much is in each tail?
40.
Right. So you want to find the z-score here, and then the z-score, yeah, for 40 and 60. Yep, sorry. Yep, you're accepted. Okay. All right, so there's your values. Check those. But let's go on to number 7. Okay, so here's the deal. Number 7, starting with this kind of problem, this is the actual way that you're going to have these kinds of problems. Everything that you've done up until now has been just basic skills that you've been getting, learning how to punch numbers, get the z-scores, learning just the basic skills computation of a normal curve. From here on out, this is the way that you will see problems on quizzes. This is the way that you will see problems on tests. You're never going to see something where it's just straight up, find the z-score for this. No. It's going to always be in context. So, here we go. Number 7. A pizza parlor franchise specifies that the average amount of cheese on a large pizza should be 8 ounces and the standard deviation only 0.5 ounces. So, I generally like to write out my information as I go. Okay. An inspector picks out a large pizza at random in one of the pizza parlors and finds that it is made of 6.9 ounces of cheese. Now, question, what variable would we represent with the 6.9? Very good. Our actual piece of data that we are finding from our individual sample is 6.9 ounces. Very good. So that would be the X. So if the pizza parlor is really putting 8 ounces of cheese on the large pizza, what's the probability that the randomly chosen pizza that the inspector has chosen has 6.9 ounces or less? Alright, so I personally like to sketch a picture of what the question's asking. So it's asking for a probability. So in my mind, it's looking for an area. Okay, so I'm going to draw a picture of what this problem wants. The middle is 8. I find something at 6.9, and what physical concept is it looking for on this? What physical concept is it looking for? Well, you have to find the z-score to get to your ultimate answer, but I'm finding the probability. Well, how do I represent the probability here in my picture? Good. It is this shaded area. So this shaded area is ultimately the value that I am looking for. Okay? Because this shaded area is going to be the probability of getting a piece of data inside that section. Okay. So you were correct. I have to get a z-score first. So I'm going to do that. So z equals data minus the mean over the standard deviation, and that is negative 2.2. The fact that this is over 2 standard deviations below the mean is already making me think what? That it's an outlier. Okay, so he happened to get something that was pretty rare if 8 ounces of cheese are really being put on those pizzas on average. All right, but let's go ahead now and find this actual shaded section. And so here's how you notate that. Here's how you write your answer. The probability that we get a z-score that is less than negative 2.2 is, and then we're going to now use our calculator and get the answer. What calculator step do I go through to get that? It's norm CDF, getting the cumulative area. So norm CDF from what? What's the lowest z-score down there at negative infinity? Negative 99. I simulate by negative 99 up to what value? Negative 2.2. All right, and that is 1.39%. Okay, so the probability that I find a z-score that's less than that is 1.39%. Now, just FYI, you could have found this on the here really easily. Look, there it is. Negative 2.2, 1.39%. Okay? So I do not care if you use your z-chart or if you're using your calculator. Either way, you're going to come up with your answers easily. Okay, so let's go back to this. Yes. Yes, on the AP test, you can use any of those charts that I gave you. Those are all available to you on it, and your calculator. Okay? So I never am going to teach you something that you don't have, that you can't use that reference. Okay? Hey, I actually want to kind of plant a little seed of a conceptual idea for the entire second semester. And here it is. Okay, you ready? Think about this 1.39%. How likely is that? I mean, that's, statistically speaking, is that a very probable chance that he would have gotten that? Okay, no. So technically in statistics, we say this. He really would not have gotten a pizza in this section down here if they are really putting out 8 ounces of cheese on average. I'm going to say that again. Since we got this down here and it was so unusual to have gotten, in a sense, this must be wrong. We end up rejecting this notion, saying, yeah, I'm saying you're not putting out 8 ounces of cheese on average. In fact, I say that, I challenge that and say that you're actually putting out something that is less on average. We never get to say specifically what that is, but we just say it's something lower. Okay? So that's what the whole second semester is based off of. Challenging this number that is put forth and seeing if you have evidence to reject it or not. Okay. Next, number 8. If the amount of cheese on the pizza is 3 standard deviations below the mean, then the pizza parlor will be in danger of losing its franchise. What's the minimum amount of cheese that can be placed on a large pizza according to the standards for the franchise not to lose its license? Okay, so this problem is saying 8 is what's happening, but if you are down here, if you're down here at 3 standard deviations away or less, then you could lose your franchise. Basically, somebody's going to come in, retrain everybody, and see if we can get this fixed. So, ultimately, what question am I asking for? Am I looking for an area, or am I looking for a z-score, or am I looking for, like, the real-life piece of data? Good. I'm looking for X, the real-life piece of data. I want to know how many ounces of cheese falls on this line right here. So, you have 2 ways of doing this. You can either say this, conceptually, just like what's really happening is the mean minus 3 standard deviations is going to end you up at 6.5 ounces. Okay, so if you say that, if you do that, fine. If you want to just plug and chug through the formula, here's the formula, and let's put things in. Okay, this Z is -3 because it said 3 standard deviations below. So therefore the Z is -3. X is what you are solving for. So you leave that as a variable. The mean is what? 8. The standard deviation is 0.5. Okay, and then from there you do algebra and you come up with the same 6.5 ounces. Alright, so there's your 2 different ways on how to do that. Okay? Alright, I want you to, on your own, take a moment and do this problem, see if you can come up with what you got on that one. Okay, so while you guys are computing that, since I had the recorder off, I'll just kind of re-say this. What? No, I don't think so. You can't turn off the recorder. Oh, yeah? Really? How can you do that and not select? You're kidding? Because that would really be bad. Okay. Do it anyway. There you go. So we have the 2 Z-scores. Probably somehow you could, yeah. Let's figure it out. I think I'm pretty much the only one who does that. Yeah. It would just be really annoying. Okay, so hopefully you can do the math on that. The answers that you get are 20.62, and then you would want to put the units because, see, we're putting it in context. So that is the lower bound, and then this is the upper bound. So let's think about this in terms of like if you were an inspector. If you were a city inspector in Los Angeles, and you needed to make sure that you had at least 85% of people, then you would need, or 85% of the mobile homes within specifications. And anybody below this amount or above this amount is going to be outside of specifications. Okay? So if like federal guidelines came down and said you need to have at least 85%, then we would identify this, and then we would be able to see if they are within specifications. Okay, so again, your homework is to complete the rest of these quote-unquote notes. They actually are not too involved in words and stuff, but there you go. You're going to finish those. We'll check them tomorrow, and then we'll do more problems on applications tomorrow.